Greetings, mathematicians. So in this video, we're going to take a look at finding absolute minimums or absolute maximums for polar equations. And so in this problem, we want to find the value of theta in the interval 0 to pi over 2, including 0 and pi over 2, where we have the shortest distance to the pole. So the first thing that we want to do is figure out our critical points. And our critical points are going to be when our r prime of theta is either undefined or equal to 0. Okay, so for our first step is let's calculate what r prime of theta is. The derivative of -4 is 0. The derivative of 1 theta is just 1. And the derivative of of 3 cosine of negative theta is going to be -3 sine of negative theta, but then I need to multiply by a -1, which is the derivative of the inner function, negative theta. So I multiply by a -1. And so if I simplify this just a little bit, I get r prime of theta is equal to 1 plus 3 sine of negative theta. Okay, so now I'm going to set this equal to 0. All right, and I'm going to figure out what the value of theta would be that would work for this. And then what I'm going to do is I'm going to make a table here, and I'm going to figure out, based upon my endpoints, whatever I get for my critical point or points values and my other endpoint. I'm going to figure out what the overall distance is from the pole. So I want the magnitude of the radius value. All right, so let's go ahead, and I am going to grab our calculator here. And so let's grab our NumWorks calculator. Okay, and for this, I am going to enter into my grapher. I am going to first go to the templates, and I'm going to go down to my r of theta function, my polar equations, and I'm going to enter the original function. I'm not going to enter the derivative that I calculated by hand. Depending on the problem, you might have to solve the equation by hand, or sometimes you might need to find it using the calculator. So I'm going to enter -4 plus theta plus cosine, 3 cosine of negative theta. Okay, I'm going to hit OK. And now what I'm going to do is I could either use the grapher to figure out where the radius is 0, or I'm going to go over to my equation solver. I'm going to hit OK, and I'll add, this time I'll add an empty equation, and I'm going to go to the var key, the VAR key, and I'm going to grab R1, which is stored in the grapher's memory, and I'm going to select theta by hitting this 4 times. So I hit the X, N, T button, and if you cycle through, you get X, N, T, then theta. So I want to know when the derivative of this function, so I'm going to hit alpha, toolbox, to put my prime after the 1. And I want to know when this is equal to a value of 0. I'm going to hit OK, and then I will go down to solve equation. So the first place in our interval 0 to pi over 2 would be a value 0.3398. Now, I am going to store this value. So I'm going to store this by hitting Shift and the X to the Y key to get the arrow. And then I'm going to hit alpha and A alpha and the e to the x key to get a, and then I'm going to hit execute. Okay, now if I go back to my home screen, all right, and let me just make sure by typing alpha A, I'm going to make sure that that's got stored properly. Okay, so I want to figure out what is R at my I want to figure out my R value here at 0, at 0.3398, so on and so forth. I could continue on with decimals. As long as I'm rounding for the AP to 3 decimal places or more, we're okay. So I'm going to go ahead and hit the var key, and I'm going to go to function, hit OK, and I'm going to grab our R1 by hitting OK, and I'm going to plug in 0. So my radius value is -1, so the magnitude of that is +1. So I'm 1 unit away from the origin, 1 unit away from the pole. All right, I am going to I'm going to go back up and hit OK on top of this to grab it again. And this time I'm going to enter alpha and A, and I'll hit execute. And that gives me -0.83. So the magnitude of that would be 0.832. And now I'm going to go back up and I'm going to arrow over and hit OK to grab the R1 of A. And this time I'm going to change the value to pi over 2. And that gives me a value for R of -2.43. And so the magnitude of that is going to be 2.430. Okay, so where do we have the absolute minimum distance to the pole? Well, from these 3 values, our absolute minimum distance, the absolute minimum distance from the pole is 0.832, which occurs at theta equals 0.340 radians. Okay. So be on the lookout for more polar coordinate calculus videos.